Okay, so I'm going to do a video for you guys. This is circular permutations. This is number 22 from the book. And so it's for this first one here, we're going to have A, B, C, D, and E. How many people do we have here? Well, there's 1, 2, 3, 4, 5. Okay, so if we were lining these people up, okay, it would be 5 factorial. No problem, all day. But since we're in a circle, what we need to do is we need to pick someone to lock in. Okay, so we're going to have A lock in here at top. Why not start with A? Okay. How many ways can we choose A? Well, there's only one way to choose A. For the next spot, how many ways can we choose B, C, D, or E? Well, there's 4, followed by 3 choices, followed by 2 choices, followed by 1 choice. Okay, has this sat all 5 people? So A, B, C, D, E, all 5. Yeah, so 1, 2, 3, 4, 5. So the answer here is going to be 5 minus 1 factorial, or 4 factorial. Okay, so again, we have to lock someone into place or it's not going to work on these circles. Let's take a look at QLMTXN. Okay, so let's lock someone in. It doesn't really matter who we lock in. Someone just has to be locked in. So we'll put X in here in the fixed position because there's an X in my name, so why not? How many ways can we choose X? Well, there's only one way of choosing X. Next, we will sit... well, it doesn't matter who we sit. How many choices do we have to sit, though? We've sat one person. We have 1, 2, 3, 4, 5 more ways to sit someone. So there's 5, 4, 3, 2, 1. So there were 6 choices here. 6 equals n, which then becomes 6 minus 1 factorial, which equals 5 factorial. Okay, so again, we're just going to take 1 and subtract it and then do factorial, and that's how many we can do in a circular rotation or a circular permutation. Logarithm, how many are here? So 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9. So we're going to do 9 minus 1 factorial, which will give us 8 factorial. Okay, so on this problem, it's number 34 from the combinations section. Here we have 10 cans of soup with no labels. Okay, 2 cans of soup are known to be tomato, but we don't know which ones, and 8 cans of soup are known to be vegetable. But again, we don't know which one. Okay, so part A asks, what is the probability of exactly 1 can of tomato out of 4? Okay, so this tells us we are selecting 4. These are the important things to set up for yourself right here. Is we want to break it down into what subgroups do we have, okay? We have 2 different subgroups here, tomatoes and vegetables, okay? And how many are we selecting at a time? Well, we're selecting 4 at a time. So we want exactly 1 can of tomato. So we need to ask ourselves, how many cans of tomatoes are there? There's 2 cans of tomatoes. How many do we want to choose? It says exactly 1, so we're going to choose 1 can of tomato. We'll multiply this by how many cans of vegetable are there? There's 8. And how many of the vegetable cans do we need to select so that we are selecting a total of 4? Well, we've chosen 1 already with our tomato can, so we're going to choose 3 more with our vegetable can. Okay? Then we'll divide by the entire sample space. So how many cans of soup are there? There's 10. And how many of them are we choosing altogether? We're choosing 4. This is the setup for combinations. I'll allow you guys to get the number at home. Okay, part B asks for what is the probability for at least 1 tomato can? The best and easiest way to do this. Okay, the best and easiest way to do this is to say 1 minus the probability of no tomato cans. Okay, this is the fastest way to do this. There are other options. We could go through and say, what's the probability of exactly 1 tomato can added to the probability of exactly 2 tomato cans? And we could add this together, and this would give us the probability of at least 1 tomato can. But when you start getting into bigger numbers, such as what if there were 20 cans of soup? okay? And 12 were cans of tomato, and 8 were still cans of veggie, and we were selecting, say, 8. If we were doing this, and I said find the probability of at least 1, you would have to go through and find the probability of exactly 1, plus the probability of exactly 2, plus the probability of exactly 3, plus the probability of exactly 4, plus the probability of exactly 5, okay? And you'd have to find out all of these. So you'd have to keep going, plus the probability of 6, plus the probability of 7, plus the probability of 8. And then we'd be done. Okay, it's just faster if we say 1 minus the probability of none. Okay, so since this is the faster way, I'm going to do it the faster way for every time I see the word at least. So let's do 1 minus the probability of no tomato cans. Okay, how many tomato cans are there? There are 2. How many of them do I want to choose? Well, it says I want no tomato cans. So 0 tomato cans. How many of the other subgroup are there, which is vegetable cans? There's 8 vegetable cans. And how many do I want to choose? Well, I want all 4 to be veggie cans. So I'm going to choose all 4. And then I'm going to divide by the sample space, which is still going to be 10, choose 4. Okay? Once you find this, you're going to do 1 minus that to give you the probability of at least 1 can. Okay? I hope this has helped. Let me know if you have questions or comments, and I'll see you tomorrow.